Good morning, students. Today, let us see in our compiler design subject, phases of compiler, in Unit 1, the last topic of Unit 1, that is the direct method of constructing DFA from the given regular expression. I am Dr. A.K. Jaitanvi, Assistant Professor from the Department of Computer Science and Engineering, right, RMD Engineering College. Now, in the last session, we have seen about Thomson construction of converting the regular expression to NFA, then NFA to DFA, right? Now, let us see the direct method, which is one of the best method consuming only less time, right? So using this direct method, otherwise called as syntax tree method, we can convert the given regular expression directly into DFA. First, we augment the given regular expression by concatenating it with a special symbol hash. That is, when a regular expression is given, A or B, we put at the end a special symbol hash. This represents like a full stop, end of the statement, like, so end of the regular expression. The important states of NFA correspond to positions in regular expression that hold symbols of the alphabet. Now, this is the first step, right? Augmenting the regular expression. Given the question A or B star ABB, right? What we do is we keep the operator correctly. First, open parenthesis, A, concatenation, that is OR operator, then B, close bracket, then we have the clean closure, dot operator, then A, dot operator, B, dot operator, B, and the end of the regular expression, hash, right? Now, let us see the steps for converting regular expression directly to a DFA. Now, construct the syntax tree. Traverse the tree to construct the functions nullable, first post, last post, and follow post. Next, compute the follow post, right? Because in the tree itself, we'll be finding out the first post and the last post. After we find the first post and the last post, we are supposed to find the follow post. Then we can directly convert the regular expression into DFA. Now, regular expression is represented as a syntax tree where interior nodes corresponds to operators, okay, representing union, concatenation, and the closure operations. Leaf node corresponds to the input symbols. Now, construct DFA directly from a regular expression by computing the functions nullable of n, first pose of n, last pose of n, follow pose of I from the syntax tree. Let us see what is what. Now, nullable of n is true for clean closure node and the node labeled with epsilon. So you know that nullable means empty. For other nodes, it is false. Next, we'll see first pose of n. Set of positions at node ti that corresponds to the first symbol of the sub-expression rooted at n. Last pose of n. Set of positions at node ti that corresponds to the last symbol of the sub-expression rooted at n. Then follow pose of I. Set of positions that follows the given position by matching the first or last pose of a string generated by the sub-expression of the given regular expression. Now, let us see the rules for computing nullable, first pose, and the last pose. Okay. Now, next, given the node n, a leaf labeled epsilon, right? So nullable is true. First pose and last pose will be null. When it is epsilon, it means it is empty. So there is no first position, there is no last position. Then a leaf with position I, right? It is not nullable, so false. So first pose is the position itself. So my dear students, see here, no, we are supposed to give the position. A or B star ABB is there, no? So you are supposed to give position for the strings. That is, A is given as a position 1, next B is given as a position 2. Once again, the third A is given as, third symbol is A, that is given as position 3. Then B is given as position 4. Then the last B is given as position 5. It means that we have A, B, B with the position number 1, 2, 3, 4, 5 respectively. So that is what they mean here. Okay. Now, and node or node n is equal to C1 or C2. Right. So C1 or C2 means either nullable of C1 or nullable of C2 union. So it is first pose of C1 union, first pose of C2. Similarly, for last pose also, we will be doing the last pose of C1 union last pose of C2, right? Then concatenation. So it is an and. See, sorry, students. Okay, so here in the case of OR node, okay, an OR node, it is what you say, it is like our logical OR operator. In the case of concatenation, it is our logical AND operator. So nullable of C1 and nullable of C2. Okay, so if C1 is nullable, then it is first pose of C1 union first pose of C2. If suppose C1 is not nullable, so in that case, it is just first pose of C1. For the last pose, it is same as your first pose. Then the last one, a star node n is equal to C1, clean closure. So in that case, nullable is true because what is going to be a clean closure? 0 or more number of times. It means that the given string will have epsilon, right? Now, the first pose of this respective node will be first pose of C1, and the last pose of the respective node will be the last pose of C1, where the C1 is his immediate child. Now let us see the rules for computing the follow pose. The position of the regular expression can follow another in the following ways. Right. So this is a rule. If n is a cat node with left child C1 and right child C2, then for every position I in last pose of C1, all positions in first pose of C2 are in follow pose of I. For cat node, for each position I in last pose of his child, left child, the first pose of his right child will be in follow pose of I. If n is a star node and I is a position in the last pose of n, then all positions in first pose of n are in follow pose of I. For star node, the first pose of that node is in follow pose of all positions in last pose of that node. Let us see the example, right? R is equal to A or B star ABB. So as you all know, we are supposed to do the augmentation and put hash at the end. So what is the position number you have? 5 position number. Okay, so we have 5 position number, right? So A, B, A, B, B, B. 1, 2, 3, 4, 5. Now, this is the way of constructing the syntax tree for the given regular expression A or B star ABB. So this is just similar to your syntax tree of your common expression which you have studied already, right? So you have here A or B, right? Then clean closure will always have only one child, then dot A, then dot B, then finally dot hash. So the position of this A is 1, this B is 2, this A is 3, this is 4, this is 5, and the last hash is 6. Now, let us find out the first pose and last pose in the next slide. Right, next we need to evaluate 4 functions, nullable, first pose and last pose, and follow pose from the steps. So we will get the first pose of, so this A position is 1, B position is 2, this A position is 3, B position is 4, this B position is 5, this hash position is 6. So the first pose of all the leaf nodes having operands is itself. The last pose of all the leaf nodes having operands is the node itself. Now for OR operator, either you can go for A or B. So first pose and follow pose can be 1 or 2. And the clean closure, the first pose and follow pose will just carry over from its child. When you come to this dot, its left child is clean closure. So if it is nullable means we should do union of first pose of this clean closure and first pose of this right child. 1, 2 union 3 is 1, 2, 3. Right. So the last pose is your first pose of this right child alone. This is the algorithm. Similarly, for this dot operator, it is having the right child and it is not nullable. In that case, the first pose of this child will just carry over. For this dot operator, its clean closure is nullable. Okay, whereas for this dot operator, its left subtree is not nullable. Right, your last pose will be the right child number, that is 4. So similarly, we find for this, and similarly, we will find for this dot operator. Now, next step is we are supposed to find the follow pose. Now, let us compute the follow pose. Right, so in the previous example, so in the previous slide, right, A is followed by whom? A can be followed by A, B, or this 3, because this star AB is the clean closure, right? It can be nullable. Okay, so we find that the follow pose of your position number 1, A is 1, 2, 3, and for B, A or B star, right? So it can be followed by A, it can be followed by B, it can be followed by the third A, right? And right now for this A or B star, we have found the first follow post. Now if you take A or B star dot A, right? Now who can follow this A? Who can follow this B? Who can follow this B? So this A3 will be followed by B4. B4 will be followed by this B5, and this B5 will be followed by this hash 6. So you can find 3 followed by 4, 4 followed by 5, 5 followed by 6, and 6 is followed by nothing, so it is hash. Now we are supposed to construct the D states. Okay. Now we are supposed to construct the D states, the set of states of the DFA D and DTran, the transition table for D. The start state of this DFA D is first pose of the root. The accepting states are those containing the position associated with the end marker symbol hash. According to our example, the first pose of the root is 1, 2, 3. Now let this state be A. Consider the input symbol small a. Right? Now positions 1 and 3 are for A. So let B is equal to follow pose of 1 union follow pose of 3. Right? So follow pose of 1 is 1, 2, 3. Follow pose of 3 is 4. If you make union, it is 1, 2, 3, 4. Since this has not been yet seen, your DTran of A comma A will be your B. When we consider the input B, we have only one letter, that is 2. Right? Now follow pose of 2 is 1, 2, 3. Already we have given this 1, 2, 3 as A. So we need not give a new state name. So DTran of A comma B is A. So my dear students, be clear. Now here A is the first pose of the root. Right? And then you are supposed to follow the transition for small a and small b. The transition for small a, small b, this is not like your NFA, DFA. Here what we do is, whatever is the position letter, that follow pose you are supposed to union. So similarly, you should do for the other states. So you should do for DTran of B comma A, DTran of B comma B. So finally, continuing the above steps for the rest of the states, we arrive at the below transition table. Okay, so here A is the accepting starting state, D is the accepting state. So this is the final transition diagram, okay, DFA for the given regular expression. So without constructing Thompson construction method or without using subset construction method, just by syntax tree method and with the simple logic of first pose, follow pose and last pose, we were able to find the DFA transition table. Thank you, students.